Alright, this is Wally and Jenna doing problem number 4. Take like 3 billion. This is like the fourth time I'm trying to do this, so hopefully it works, guys. Alright? I'm gonna read the problem. It's problem number 4. You may not use a calculator for this problem. Solve for the angle A in this triangle. Angle, I'm gonna give you the size right here. Side A equals 3, side B equals 4, side C equals 5. Do as much computation as possible. Your answer should be angle A equals something. So Jenna just drew the triangle over here, and she labeled the sides. She's solving for the angle opposite of 3, which is angle A. So there's two ways you can solve this. We're going to show you one that involves a lot of work, and then just kind of check your work. This is a side problem, so you can use those 3 theorems that we were given, the squared ones. So we're going to do 3 squared equals 3 is side A, okay? So it's like A squared equals B squared plus C squared minus 2 times B times C and times cosine of A, because we're solving for that angle. Okay, that's going to equal 9 equals 16 plus 25 minus 2 times 4 times 5, which is negative 40, cosine of A. You're going to 16 plus 25 is 41, so you're going to subtract that on over to the other side, and it's going to be negative 32 equals negative 40 cosine of A. Okay, so now that's going to equal 4 over 5 equals cosine of A. But now, since you're solving for the angle, you have to take the inverse of cosine of A, making your answer cosine of inverse 4 over 5. Now you would plug that into the calculator and get your exact answer, but we're going to leave it at that for now, all right? All right, so Jenna's going to explain the second way of doing this problem, all right? Here you go.
Okay, so the easier way to do this is if you just take the cosine of the triangle of angle A, which would just be adjacent over hypotenuse. So that would just be 4 over 5 if you're looking at the triangle. And then you just take the inverse and you have your answer.